Welcome to this video. Let's talk about single page applications right now. So you should know that a web browser, which is actually a program for sure, is capable of running a complete application. Single page applications are exactly this. They are complete applications that are running on the user's browser, right? So it's an application that is running in the user's browser. The single page application can handle many tasks locally rather than sending requests to a server. They work like desktop applications, but they run on the browser and the user sees the latest version of the application every time he's opening the page. Page navigation and many other interactions that would require sending requests to a server in a traditional multi-page application are done locally in a single page application. So in a single page application, we really have a lot of less server communication. The application, however, chooses to send a request to the web server whenever necessary. So for sure there is still server communication, right, for accessing data from a database or whatever. But it absolutely depends on the application, like on how we develop it. Not every time when the user interacts in any way, like in a traditional multi-page application. So just keep that difference. In a single page application, we have less server communication because we are preloading the application and its pages. And in a multi-page default application, we communicate with the server every time the user is interacting. So first, the browser downloads a single page application from a web server with all pages, including the HTML, JavaScript and CSS styles. This is what I mean by preloading. We are loading everything from that single page application. Then the browser runs the application in a single master page named index.html. This index page stays open until the user closes the browser tab, refreshes the page, or opens a link to another website. So in a single page application, we have a single page, which is like a container for everything. In other words, the index page won't be reloaded or replaced by other pages of the application while a user is using the app. Only the content of the page may change. So changing the content of the index.html may give the user the impression of loading a new web page, but it's not happening, right? He's just switching the content of the same page. From that point on, the browser requests pieces of data it needs rather than downloading an entire web page each time, because all pages are downloaded initially. So instead of like every time downloading web pages, HTML, CSS, JavaScript, etc., we are instead preloading all that information and just requesting data from a server. Well, and data is most of the time very optimized and short in comparison to JavaScript, HTML and CSS. So just think about like 100 entries of JSON data, they would just be like around some kilobytes. But a CSS, JavaScript image, something like that, which is embedded in HTML, could potentially already be around like a megabyte. Just to give you any numbers so that you see what's the benefit of an SPA. Now it's time for a demonstration. In this demo, we will create a new Angular and ASP.NET Web API application. We will run that application and then explore files and folders in the solution to see how they are structured. See you in the next video. Okay, so now let's explore the template of Visual Studio 2022 for ASP.NET Core and Angular. So you don't have to follow along. During this challenge, you will have enough time where you can completely write code and figure out things on your own. So let's create a new project right here. Let's search for a template, search for Angular. You can see the first one here saying ASP.NET Core with Angular, and that's exactly the one that we need. A project template for creating an ASP.NET Core application in combination with Angular. So I go ahead and select it and click on Next and give it a name. I'll simply call it Test Project. Now I select .NET 6. No authentication type and click on Create. So now let's simply hit Start to start the debugger and launch our application to just get started and to see what that template is delivering us. And the first thing to mention is, take a look right here. Restoring dependencies using NPM, which is the Node Package Manager. And this is because Angular is using Node.js. And Node.js is offering, well, additional packages which contain JavaScript code, for example, which get delivered over NPM, which is the Node Package Management System. So NPM is Node Package Manager. So this is just some information for you. So now you know that Angular is using Node.js. So once all dependencies for Angular are installed, you will get to that page here. He's still launching the single page application proxy, right? You can read it here. Let's give it some moments and then it should be working. Now you can see that our project is loaded and it looks like the familiar MVC template that you already know. Let's just take a look on what we have right here. As you can see, it already provides us some information, right? So we're using ASP.NET Core and C# for cross-platform server-side code. So for server-side, right, we use ASP.NET Core. For front-end or client-side, we use Angular and TypeScript. And for styling and layout, we still use Bootstrap, which is just a CSS styling library. Now, this is the home page. When we click on Counter, we will come to an Angular component. This is what it is, and we can increment it. We will take a look at that just in a second. And we also got a fetch data link right here where we get that default weather cast information, right? So this is what the template is delivering us by default. So let's switch back and see how it looks like in the folder and project structure. First of all, let's start with the things that you already know. Here we have that program.cs file again, which is just a configuration of our ASP.NET Core backend. And as you can see, it still looks exactly how you know it, right? Again, we have that configuration here, we have that map routing here, we still have controllers and views, right? But we are not returning any HTML here, we are just returning data, and the HTML gets rendered by Angular. However, all of this will be covered during the course. I will just explain what we can see here. We still have that weather forecast class. This is simply what we have seen when we clicked on forecast. And we also have a controllers folder with the weather forecast controller, but this time you can see a difference. So there are two attributes that you can use. One is controller and one is API controller. And API controller is for external usage, so that another project, for example our Angular project, can connect to this controller. If you simply use controller, it will not be available from outside of this project. Now, as you can see, we have that HTTP GET attribute right here, which decorates that GET method right here. So our API controller has a GET endpoint. And this one is simply returning some fake weather data. So, okay, this is what you already know, right? So the main difference is that we have the API controller attribute here instead of the default controller attribute. Now let's close the folder and go to pages. So all of the content that we can see, all of those pages like the counter page, like the forecast page and the home page, they are not coming from here. They're not coming from pages, right? And that's totally fine, because who cares about our pages? It is Angular. It's the single page application which we create with Angular. And we can find Angular here in client app. So let me get that clear. When we created that project, we created two applications. We created our ASP.NET Core backend application and we created our front-end client-side Angular application. So our program.cs defines our backend ASP.NET Core application. And our client app, this is the home folder for our Angular app. And once you open it, you can see that we have a lot of JS and Angular stuff going on right here. When we now go to source folder here and open up the index.html, you can see that this is the container which we have talked about when we discovered single page applications. So this is where everything is going on. We will come to that later again. And here you can see when we open up the app folder, you can see counter, fetch data, home and nav menu, right? So you already get the idea of how it's structured, right? So inside of that home folder, we got the home component, which has an HTML file. And here you can see, hello world, welcome to our new single page application, right? And once we started the application, we exactly saw that content, right? So this is what we can see here. Okay, so now you should have a first idea of what is going on. We have our ASP.NET Core backend, which is handling the request, and we have our Angular project, which is handling displaying the views, etc. And you can see that it's incredibly fast when I go or switch between home, counter, fetch data, right? This is super fast. And you can even see that the page is not reloading at all. On the top left corner, you would by default see a reload icon here when I click on the link. But instead of reloading the page, only the content is swapping. So only the content inside of that single index file is changing. This is why we don't have any loading time right here. So this is really amazing. And now you have already really learned a lot of stuff, I guess, but we need to proceed here. We need to prepare you even further for that challenge so that you really get the most out of it, because we have a huge goal, right? We want to get you job ready as a web developer. And this is why we now go ahead and take a look at TypeScript. Because when we click on the home component.ts right here, we can see that this is written in TypeScript. So let me give you a quick introduction into TypeScript, and you don't have to worry if you are familiar with C#. This will be very, very easy for you. So you will not learn a completely new programming language now, right? This is not what it's about. It's just a quick talk about what TypeScript is, how methods are working and all that stuff. We will just go through all of it real quick, but you will have no problems at all in writing TypeScript code. Alright, so see you in the next video. Let's talk about TypeScript. Welcome to this video. Let's talk about TypeScript in combination with Angular. As I already said, Angular uses TypeScript by default for developing those single page applications. TypeScript is transpiled to JavaScript to be interpretable by browsers. Browsers by default run a JavaScript engine, so they can interpret JavaScript language by default. JavaScript itself is a dynamically typed language. It checks the variable types at the runtime. TypeScript, on the other hand, is a superset of JavaScript for design time support, for type safety and tooling. Just like C# file extensions, which are CS, TypeScript file extensions are TS. TypeScript is created by Microsoft. The syntax has many similarities to C#, which is good for you, right? And this is a TypeScript class, for example. So you can see just in C#, we also here got the class keyword, for example, the class name and the curly braces. So just as in C#, you can see the class keyword here, the class name and the curly braces. To make a class accessible from the outside of this file, we should export it. So in C# you would use something like public, you would use those access modifiers. If we want to here make use of that class, we will have to export it. That's why we use export here. And always be aware that TypeScript is a case-sensitive language. So as in C#, keywords are written in lowercase. For sure, you can also define a field in a class, just as in C#. Here we can see a field called title of type string. Notice that we first got the name of the field, which is title, and then the type value, and then the type of that field is assigned after the column that we got right here. So this is the name, and it is of type string. You can also set a default value for the field and change it as it's needed, right? Just as in C#, here we got a default value now, which is a string for sure. And TypeScript automatically infers the field type when you initialize the field with a default value. So TypeScript can see that now the title is a string, so we don't have to define the type manually if you don't like to do that. So we can skip defining the types explicitly to make the code easier to read. So let's skip defining the type here. And based on the default value, it infers that the type of this field is string, because we're using a single quote right here. If you would like to create an array, you would follow exactly the same pattern as in C#. You have that default array braces, and items are comma separated inside there. One thing to mention is, in comparison to C#, you don't have to define or predefine the length of the array. So here we can simply add and remove elements, right? At C# you have to say, okay, I want to create an array with like 10 or 15 elements. But here it's exactly the same rule. Since the type is inferable from the initial value, we can also here omit the type definition. So we can here also say items is an array instead of, like here, saying it's a string array, right? It automatically get inferred. So TypeScript can see that this is an array of type string. Okay, let's stop here. Let's make a short break. And in the next video, we continue talking about some more advanced TypeScript, such as classes and some more stuff. Welcome to this video. Let's talk about some additional TypeScript information for you. So we stopped at creating arrays, and this here is how you can create a method. So just as in C#, you again have that name of a method, you have a parameter written in TypeScript syntax, so you get the name of the parameter, the colon and the type, and then you have the type or the return type of that method, again the colon, which is void. So in C# that would be void log string text, right? So void log and then parameter string text. And here in TypeScript we got log, text of type string as parameter, return type of that method is void. So from an architecture side it's exactly the same, but from a written side we changed the syntax and the keywords just a little bit. You can easily define variables in method bodies, just as in C#. So here we have a variable var message of type string, and the value is message, and it includes the parameter right here. So it uses the parameter. TypeScript again is capable about seeing that this variable here is a string because we are assigning a string right here. So we can shorten it up and remove the type definition. So var message is equals to message and the parameter text. So this is exactly how you can also write it down in C# code. Now if you want to call a method, you can go ahead and do that just like this, console.log message. This would for sure print out a message into the console, but just as in C# you call the class and then you call that method and then you paste in some parameters to provide the method some information. Methods are public in TypeScript by default, that's important. So private methods should be marked explicitly using the private access modifier. So as we got that here, private log, right? So if we just say it like this, log, then it's public by default. And if we want to make that private, we do this by using private keyword access modifier. Like fields and variables, you can omit method return types when they are inferable from what the method returns. So here we got the private log method, and we can remove the return type void here. Here, for example, we got the sum method, and the parameters are of type number, A and B, right? And we can remove the return type of that method because we are definitely returning a number here because we are using A and B. So if we use A and B and they are both of type number, then we will here return a number 2, so it's inferable and we don't have to define the return type right here. Now you can see that this keyword right here, and it's mandatory before fields and methods in TypeScript when you want to access them from within a class, right? You know that from C#. Let's just assume you are creating an instance of that app component here, right? So you have a class in C# called car, and when you create a new car using the new keyword, then you have an instance, right? That's because C# is an object-oriented programming language, and such as is now also TypeScript, well, sort of. So, and if we create an instance of that app component and we want to call something on that instance or change a field or something like that, we have to talk to exactly that instance, and we can do that by using this. So if we create an instance of app component and we want to call inside of that class a method, then we go ahead and call this instance.log, right? So this is always referencing that one instance that we are talking to. I mean, that's pretty basic computer science knowledge when it comes to object-oriented programming. So just keep in mind, you can create instances of classes, for example, and if you want to do something within this class, you will have to use this keyword. Alright, let's move on. So here you can see that we can omit semicolons as long as you write different comments in different lines. So we don't have a semicolon right here because we are writing 2 comments in 2 lines. If we would go ahead and write this.log B right behind this log A, then we would have to use a semicolon for sure, but that's how it's also working in other programming languages. So as long as you write a comment in each line, you don't have to use semicolons at the end of your comment. Now TypeScript has some primitive types built in, which are number, string and boolean. This is just like number, like float, integer, string, you know that from C#, and boolean is the bool from C#, right? You can also define variables of the type of classes. So here we got a variable with the name app of type app component, and it's a new app component, right? So exactly how you would write it down in C#. Well, you would not use that column, but that's not really important. But you can here see that we create a new instance of app component by using the new keyword. And here we got that nice constructor called, which will get called when the instance is created or during the instantiation process. Let's move on. This is how you can define arrays. So you get a variable with the name A. It's a array of type number, array of type string, array of type boolean, and even an array of our custom type, for example, app component, which we could have just created. Okay, so now those are the basics of TypeScript. In the next video, we will just make a very short extension to that and talk about so-called decorators, which we can use in TypeScript, and Angular makes use of it a lot. So it's very important that we talk about that, because that's also something that you won't find in C#. So this is something for a separate video. See you there. Welcome to this video. Now we talk about decorators, and we will take a look on our Angular project to see some TypeScript in action. So this video will not be that long, and afterwards we will have completed that TypeScript section. So look at this TypeScript class right here. It has a component decorator on top of it, and Angular uses such decorators to determine how to deal with decorated classes. So for now, just keep in mind that you can use the decorator and put it right on top of a class to decorate it. Sort of like an attribute in C#. So here you can see that component decorator again, and it has some more options like the selector and template URL. See that this is an HTML file, app.component.html. Now in a minute we will swap over to our project and you will see that in action. But for now, let's stick with the theory just for a second. Angular enables developers to create custom elements in addition to the HTML element. So if you didn't know, you can create custom HTML tags. That has nothing to do with Angular, but you can do it, and you can combine it even further with Angular. So you can see this is an HTML tag right here, and that HTML tag got created by the user, right? So it's a custom element. Now in Angular, custom tags are called selectors. So this custom type here is a selector. When you create a new Angular project and open the index.html file from your IDE, so Visual Studio, the body tag will contain an app root, and we already saw that in a previous video, and the app root tag acts like a placeholder. And inside of that app root here, Angular puts in the templates that we create when we start our application. Templates are pieces of HTML code, and Angular replaces the custom tags with the templates they point to. So app root here is a template, and the content of that template is this HTML code here, right? So you got that HTML, you have another component, app.nav, or another template, and you have that default HTML elements here, and the app root will get replaced with its template code here in runtime. So this is what Angular is doing, right? It's replacing the tags with the templates they point to. And as I already said, templates may also point to other templates internally. So here app.nav menu is another template, and router outlet is also another template. So but how does Angular know which template to render and replace with which tag? An Angular component is a TypeScript class that can specify which template to be replaced with which tag. So you got that selector here. Just remember that component decorator we have just seen a couple of slides ago, and here we have that app root selector. So we define it here and we say, okay, go ahead, and every time you find that selector, replace the selector with the following HTML code, which is exactly this one here for this example. When you create a new project, the app component exists in it by default. So we will now swap over to our project and take a look at the app component and see if we can find that component inside of our testing project. Okay, so here we are in our project, and when I now open the client app folder, which contains the Angular project, and open up the source folder, you can see that we here have the app folder, and inside that app folder we got the app component HTML. Let's open that up. So here we got the HTML part. Let's switch to the app component. You can see this is TypeScript. We have that decorator here, right, which has the selector and the template URL. And when we now open up the index.html, which we have right here, index.html, you can see that app root here. So app root, this selector will be, or this tag will be replaced with the content of that app component HTML, because in our app component we have that selector app root. So go ahead and take all app root tags and replace them with app component HTML. So here we got an app root, and it will get replaced with this HTML template code right here. So this was just to get you started with Angular. Don't worry too much, we will get through all of this in detail while writing some code. So yeah, let's sum it up. So this is the end of day one. It was a lot of theory, but that's very important when it comes to computer science. So today was the only day where we really talk so much about theory. Over the next days, there's so much more practice stuff so that you really get your hands dirty writing code. Let's just recap what you have learned today. Multi-page applications render each page on the server side and download the page each time the user navigates to a new page. Single-page applications usually download the template for all pages by the first request and request for the missing data when necessary. And Angular is a component-based single-page application technology which uses TypeScript for development. Also, for sure, we took a look at TypeScript in general, and I briefly introduced you to the topic of Angular decorators. Alright, I hope you enjoyed day 1 and I'll see you tomorrow in the next video.